Hey everyone, welcome to your Play Posit for Monday. I hope you guys had a great weekend. We are going to be covering some topics in Unit 3, mostly proofs, as we are continuing our notes from last class. So go ahead and grab your notes for today and we'll get started. Before then, I wanted to take you on a quick OMHS tour. You may have seen some assignments added to your plan, I don't know, maybe a few weeks ago, last week. But our constructions unit in the OMHS is not as detailed as I would like. So I added some items for us so I could make sure that you guys are all up to speed on that. So you'll find them on your plan for, I believe it's Monday, Tuesday, and Wednesday of this week. But let me just show you in content, which is where those plan links will take you. And there's 3 items to complete. 2 of them are ungraded and 1 is graded. They are all still required, but just 1 has the grade. So you'll find it in our Unit 3 geometric constructions, and there are 3 parts. So the first part is a document that has maybe 6 or 7 videos for you to watch and practice along with the video, creating those constructions like bisecting an angle or copying an angle, things like that. Part 2 are some practice sheets for you to do it on your own, ideally without the video, right? So you've practiced with the video, you're getting comfortable with it, and then you can try it on your own. And then part 3 is the graded part. I think it's 5 questions, and it's going to be a quiz that I'm going to put in here. And they're going to be questions that are similar to the ones that you'll see on the end of course test. So on the end of course test, you won't actually have to construct anything, but we'll be asked to answer questions about constructions. And so it's really good to have the process down of how to create them, because if you can create them, then you can answer questions about them. So that's why I added these things in there for us. Get back to our PowerPoint. So here's our flashback. It's taking us back to a little bit of logic, those P's and Q's that we're used to. And again, this is another question I pulled from a previous SOL. I'm going to grab my pencil tool. There we go. So it tells us to let P represent angle A is acute. So they already told us this is P. And let Q be angle B is acute. Create a symbolic representation of the following argument. So here, remember, we're just matching up the parts of the sentences with the letters they provided. So it says angle A is acute if and only if angle B is acute. Now this if and only if is pretty special. There was a few ways that we represented that. We used IFF, and we also used the double arrow because it goes in both directions. So if you look at the answer choices, here we can use a little bit of elimination, essentially, right? There's only one that has the double arrow, and there's no IFFs. So it has to be this one. And it also matches our statements, right? A acute is P, and B acute is Q. So we're good. Now, the second statement is one we haven't really talked about in class yet, and it's the OR statement. This is the symbol for OR, a V. And this is the symbol for AND, which is kind of nice because you can imagine drawing an A for AND. So we're looking for the one with a V. So there's a few. There's this one and this one. But this one has the 3 dots. Remember, that means therefore. So it must be this one, P or Q. And that does match our sentence. A acute, B acute. Therefore, oh, that's it. So it can only be one of these 2. So it says A is acute and B is acute. So it has to be this one. Therefore, P and Q. All right. I wanted to share a little, did you know, I may have shared this with you guys last year if you were in my algebra class. I think it's so cool, so relevant, that especially with geometry. I mean, you could look at this picture and I'm sure you're already thinking of all the ways that geometry specifically was used to create this garden area. I see a lot of circles, a lot of spheres, a lot of area covered, right? You're going to need to know how much sod to cover in this area. I wish that there was like a person in here so we could see the scaling of this. Like, let's just imagine. So that grassy area is pretty big. We can see the trees, how tall they are, so that gives you an idea. So not only area and shapes and measurements and things like that, but also pricing when you're giving quotes to customers. Landscape design is a real, true job. I used to work for the National Recreation and Park Association, and a lot of our members were landscape architects. They went to school to do that. They became certified to do that. A lot of businesses, parks, even personal people would hire them to do things just like this. So how cool is that? Like to work with your hands and use math and design. I think that's cool. All right, so let's get to it. This is kind of where we stopped a little bit last time in class. We're going to do some proofs. Turn our beast mode on and get these done. Before we do that, let's review some of our tools. So we learned these congruence postulates last class, and a lot of what these postulates come from are the diagrams. So we can kind of almost ignore the explanation field. I mean, who needs a wordy definition anyways, right? I mean, we can turn this into a working postulate for us. If you see this diagram, there are 3 things marked. And what are they? They are all sides. This is the side, side, side congruence postulate. And it says if there are 2 triangles where they have 3 pairs of congruent sides, then everything about them is congruent. Here's the next one. We have a side, an angle, and a side. Well, there it is. There's the postulate, SAS. Here we have it. Angle, a side, and an angle. It's angle, side, angle. Let me move my face. And here we have an angle, and a side. An angle, and a side. That's our angle, angle, side postulate. And lastly, this is a right triangle, which more often than not, it is going to be the hypotenuse leg. But just make sure that that's what's marked, right? So in this one, it is the hypotenuse and it is the leg. You could have a right triangle like this, where you have a leg and the other leg marked. Check this out. This is not hypotenuse leg. This is side angle side. So just be careful. Usually when you see the right angle, our minds immediately go to hypotenuse leg, but it's not always that unless the hypotenuse is actually marked. Oh, one more thing. Let's review. Remember when you have 2 triangles that share a side, like that peanut butter sandwich I was telling you about. When they share that side, it means that it's the same for both of them, right? If we split this apart, this side is the same, and that's called the reflexive side. Like you're looking in a reflective mirror. And then the other thing we use a lot are vertical angles. If you have 2 angles right across from each other, you can mark them congruent. All right. Oops. Computer's going nuts. Okay, here, let's try this one. It says click and drag each selected reason to the correct box. So they give us some information. The given information is always really good because it's going to help us solve the problem. It tells us that there's a diagonal and AB is congruent to DC. So those are marked. That's great. And BC is congruent to AD. And those are marked. Perfect. And in our 2-column proof, we put that first, and the reason we were allowed to write it is because they were given. Next, you can see they wrote AC is congruent to AC. So I'm going to mark that, which you probably saw we could. What's the reason? That's that side we just talked about, and it's the reflexive property. And lastly, it tells us the triangles are congruent. So when you look at this diagram, and you can even split them apart if you want, which postulate jumps out at you? And it is side, side, side. So we would grab that side, side, side congruence theorem. Sometimes you'll see it written congruence theorem. Sometimes you'll see it written congruence postulate. It kind of depends on the author. So these are kind of like the puzzle piece proofs where you're filling in the parts. Some people really like these because there's clues given. I prefer the proofs where I get to do it all on my own because my brain just works that way. These are okay too. But for these, you're like stepping into someone else's thoughts. You know, they decided to put this down in this order and all of that. Here, we get to do it all on our own. Use our own thoughts. So it wants us to prove the two triangles are congruent. They give us that T is the midpoint of QR. So what does that mean? If T is the midpoint, what do we know about these parts? T is right in the middle. We know these are equal. And I like to just mark whatever I can on the picture with the given information before we do anything in the chart. Then it says QS is congruent to RS, so we'll mark that. Okay, lastly, do you see that reflexive side? There it is. So you may already see which postulate these are congruent by, but let's write the proof. So we always start with our given information. T is the midpoint of QR. And we would say given. And then QS is congruent to RS. And we would say given. Now the next thing we did, remember, we marked QT congruent to TR. And we knew we were allowed to do that. Why? Because T is the midpoint. So we would say definition of midpoint. All right, then what did we do to the picture? Then we marked TS. So we would say TS is congruent to TS. So you got to record everything that you marked on the picture. And we know that we're allowed to do that because it was the reflexive side. All right, and then we saw the postulate jump out at us, right? Side, side, side. So we're done. We are at our very last statement. QTS is congruent to RTS because of the side, side, side postulate or theorem. And you're done. All right, now we have 5 practice problems. So I encourage you, and I'm going to build some breaks into this PlayPosit for you to try these on your own and then come back for the answers. So these all, I think most of them have the statements written, so we're going to have to write the reason as to why we were allowed to write them. And they're kind of a little bit different. You can see that these pictures already have markings on them. It says LM is congruent to LO. And that's just given to us in the picture, right? So we would say it's given. Even though they didn't write it as a statement up here, they gave it to us in the picture. So it's the same reason. Similarly, MN and ON is given. Next statement, LN is congruent to LN. Hopefully you're seeing a theme here. We're going to see this a lot. And that's the reflexive property, right? That side that they share. And then why are the triangles congruent? Because of the SSS postulate or theorem. Side, side, side. It just kind of jumps out at you, especially if you label it. All right, let's try this one. GI is congruent to KI. Yep, sure is. And we know that because it's marked in the picture, so it is given to us. Same with HI and IJ. Then it tells us angle GIH, this one, is congruent to KIH, this one. Why? How do we know these are congruent? What kind of angles are they? And you're probably screaming at the computer screen. Your learning coach is going, what's wrong? And you're like, I'm doing math. They are vertical angles. Nice work. And why are they congruent? I'm going to change it up with a different color. Let's mark what we have. We have a side, an angle, and a side in both. So that is the side angle side congruence postulate. Shorthand there. Next one. Hopefully these are starting to feel really comfy. I know this is definitely just another style of proof. It still has the 2 columns, but instead of them writing the statements of the given, they're giving it to you in the picture. So I wanted to make sure we saw all the different kinds of ways you guys could see proofs. MLN is congruent to ONL. Okay, MLN, ONL. Yep, that's that 1 tick mark. Sure is, because they told us it was. Second statement, which angle is congruent to OLN? OLN. That's the 2 tick marks. And there's 2 answers here. You could say MNL, right? Or maybe you read it this way, LNM. Whichever way would be correct. As long as N is the vertex to get that angle. Next, look, we have to figure out the reason and which statement goes with that reason. Which statement would go with the reflexive property? Well, we know that's that shared side. So that's LN is congruent to LN. That peanut butter side. Oh my gosh, do you guys know that song, Peanut Butter Jelly Time? Look it up. I'll play it with you next time we're together. I just thought of that. Last statement, what congruence postulate do we have? We have an angle marked, a side marked, and an angle marked. So that's the angle side angle postulate. Moving right along. Angle Y is congruent to angle C. Yep. Thank you for that. In the picture, it was given to us. And what else was given? Because that's our next statement. The other thing marked in the picture is this YA and AC. So we're going to say YA is congruent to AC. You could have said AY and CA, whatever order. Order doesn't matter with line segments. Excuse me. When does order matter? We'll just do a little recap. It matters when you're talking about rays. Like here we would say ray AB, because you always start with where the ray starts and the letter goes to where it ends, towards B. We wouldn't say BA because there's no ray going to BA. Vertical angles is our reason. Here they are. So we'll say angle ZAY is congruent to angle CAB. And lastly, which congruence postulate shows that? Well, we have an angle marked, a side marked, and an angle marked. The ASA. Whoops. Last one. Angle T is congruent to which angle? It's angle V, right? They both have those same markings. And they told us that in the picture, so it's given. What else was given? And it's this other marking here. And be careful how you label these, right? We don't want to just say angle X, because angle X is talking about this whole thing right here. This is angle X. We just want this little piece. So we're going to have to use the 3 letters. VXW is congruent to TWX. There we go. We just don't want to grab the whole letter in this case because that angle is split into 2 parts. Not like this one. Reflexive property, which side is shared? Now this diagram looks a little different from what we've seen, right? We've seen ones like this. But if you can kind of see the 2 triangles, there's actually 3, but we're talking about these 2. You could even split them apart. Let's relabel WVX and WTX. Oh, now you can see the side they share. XW, XW. Or maybe you saw it before. They kind of lay right on top of each other on the base. So they both share XW because of the reflexive property. So I'm going to label what we had up given. We had these angles, and then we know these match. So which congruence postulate is shown? We have angle, angle, side. Angle, angle, side. Ooh. Let's go back and make sure. Yep, our angle, angle, side postulate. You did it. I don't know how you guys, I know we talked a little bit about proofs last time and how you felt about them, but I know when I was a student, at first, I didn't like them. 1, I didn't know why we were doing it. And 2, they were challenging to me. So I hope that I've explained enough why we're doing it. I spent a good amount of time in one of our play posits and last class kind of explaining to you the problem solving aspect of it and how proving something can be so powerful. I know that proving a little 5-sentence geometry problem is not as powerful as what I'm thinking here. But as we move on in geometry and just in life, being able to take statements and reasoning to get to your solution. or your proof. Lawyers use that a lot, using little bits of pieces